Hello and welcome to this section of the MATLAB Tutor. Here we're going to continue working with vectors, and I'm going to teach you how to use mathematical functions built into MATLAB to operate on vectors. So just to kind of ease ourselves into it, let's define some vector. We'll call it Jason. We'll open this up and we'll just put some numbers in here. We'll put 0, or we'll put 1, 2.4, or 2.2, 3, 5.6 or something like that. So we have these elements, 4 elements of vector Jason, and we've already learned in previous sections that when you take 2 and multiply by Jason, then MATLAB is going to, this is mathematically correct as well. You would just basically multiply each element by the number 2. Multiplying a vector or a matrix by a scalar just simply multiplies each element times that guy. So you can do things like, Jason divided by 2, which is basically multiplying by 1/2. So we take each element of Jason and we multiply it by 1/2 is the same thing as dividing by 2. So you can do things like Jason plus Jason divided by 2. And so what you'll get is you'll take the matrix or the elements of Jason, you'll divide by 2, so this guy divided by 2 would be 0.5, and then you add it to the first element of Jason. So you go element by element, taking half of it and adding it to the original element, according to this little equation there. So you can basically do multiplication and division on vectors and have them apply element by element automatically. All right, so what if you want to do things like define a vector? In this case we have a vector Jason. What if you want to take the sine of each element in here, or the cosine, or the square root of each element here? Now those are mathematical operations that aren't really usually discussed much when you talk about vectors and matrices. Usually you're not defining a vector or a matrix and then trying to take the square root of all the elements in there. But MATLAB, when you apply these mathematical functions, most of the time it defaults to trying to apply them element by element. So for instance, if you wanted to take the sine of Jason, then it's going to treat this as basically a list of numbers, and it's going to return another vector that's going to give you the sine of each one of these values. You might want to even define another vector that to make this a little bit easier. So you could say 0, the next element might be pi, and the next element might be pi over 2. So let's go ahead and define a vector with these 3 elements here. And you can see here I made a little mistake. You need to make sure not capitalize the p in pi. So if you ever get something like that, that's what MATLAB's basically complaining about. So here we have a vector. This is pi and this is pi over 2. So we might want to do the sine of vector Gibson. So that makes sense, right? Sine of 0 is 0. Sine of pi is also 0. And sine of pi over 2 is 1. So that makes sense. You can also take the cosine of these guys and it will be applied element by element. So we've taken the sine and the cosine of our vector Gibson, which has our nice numbers in there. We can even do things like taking the tangent of Gibson. So the trig functions basically all apply element by element. Now I want to point out, if you ever see something like this, the answer is this large number times this vector that it puts down here. So sometimes, depending on the number format you're in, instead of it doesn't have enough room to put all the decimals in the individual elements because of the way that we have the number format. It might give you a vector, and then it might tell you that this whole vector is multiplied by a large number or a very small number or something. So if you ever see a number multiplied by a vector, it's giving you the same information. It's just there's not enough room to show that stuff there. You can do things like format long ENG, and then you can do that calculation again, and then you'll see all the decimals and all of their glory there. So it's just a matter of how many decimals you have on the screen. So we've done the trigonometric functions. What else can you do with these guys? Let's bring up our vector Jason, the original one that we entered in. What if you wanted to take e and raise it to the power of each one of these things, like e to the 1, e to the 2.2, e to the 3, e to the 5.6? Well, to raise e to the power of something in MATLAB, it's the exp function, and when you pass it an argument like a vector like this, it's going to treat everything element by element. And so e to the 1, of course this is the value of e to the 2.2 power is this, and so on. So it applies element by element. What if you wanted to do the logarithm? This is a base e, a natural logarithm. If I wanted to apply this guy, then it applies again element by element. So natural log of 1 is 0, natural log of 2.2 is this, and so on down the line. It's exactly the same thing as if you had typed them in separately. It's just keeping them all encapsulated in this sort of vector format. What else is pretty common? You might want to take the square root of something. You can take the square root of this vector, and it will basically apply the square root function element by element. Now, occasionally you'll run into one of these things that doesn't quite work the way you might expect. What if you wanted to take the number 2, or let's say the number 3, and raise it to the power of vector JSON? In other words, I wanted to take 3 and raise it to the first power, and then 3 raise it to the 2.2 power, and then 3 raise it to the 3 power, and basically apply it element by element. When you do that, it says error using this symbol. Input must be a scalar in a square matrix. To compute element-wise power, use this instead. And that should ring a bell, because this little guy, if you ever run into problems doing element by element, if you get an error message, then basically the reason you usually get an error message like that is because there's some other rule of math that you're violating. Taking 3 and then raising it to the power of a vector doesn't really make much sense mathematically. So instead of defaulting to element by element, MATLAB just gives you an error message. If you ever get that, you just need to force it to work element by element. And so then you have to put the dot in front of the operator. And when we do that, we get what we expect. So 3 to the power of 1 is 3. 3 to the power of 2.2 is this, and so on. So that is about all I want to talk about in this section. Vectors are basically ways of storing lists of numbers. A lot of times you might want to operate on element-wise, is what we really call it, element by element. Taking the square root of a vector in terms of math doesn't make much sense. Taking the logarithm of a vector really isn't defined in terms of mathematics. Here we're kind of getting into that region where we're not looking for the mathematical definition of e to the power of a vector, but what we're wanting to do is do it element-wise. So most of the time MATLAB is smart enough to do that. If you ever get an error message, then you might have to force it to work element-wise, which is why this operator here that we learned with the dot is so important in MATLAB.